For this function, you can see there are a lot of transformations being applied. I start by drawing my box, and I take note of the last number in the equation, my c value. It's negative 0.5. So that means I'm shifting my whole function down by 0.5. That means my central axis is at negative 0.5. My amplitude is 2, so that means my maximum and my minimum are up 2 and down 2 from my central axis. So if I go up 2, that brings my maximum to 1.5. And if I go down 2 from my central axis, my minimum value is negative 2.5. In the equation, I have this right here, x minus 180. This 180 refers to my horizontal shift, or my phase shift. That means instead of starting at 0, I'm going to be shifting to the right 180 degrees. That means my horizontal starting position is 180 degrees. The trickiest part is when you have a k value. So in this case, k equals 3. This refers to a horizontal stretch or compression, and it's kind of the opposite of what you would expect. So we're not multiplying by 3, we're actually going to be dividing by 3. And I'm talking about the period. The period is always equal to 360 divided by k. So in this specific instance, k is 3, so our period is going to be 360 divided by 3, which is 120. So that means from our starting point to the end point, that's a span of 120 degrees. That means I'm ending at 300 degrees for this transformed function. And now for the shape of this curve, it's a sine curve, and it's negative, so it's going to be vertically reflected. So it'll have that type of a shape. To make my graph, I'm going to start with an appropriate scale. And once I have my scale, I can draw in my box. So on the left, I'm starting at 180 and ending at 300. My maximum is 1.5 and my minimum is negative 2.5. My central axis is at negative 0.5. I start on the central axis, I end at the central axis, halfway between, I'm on the central axis. I go down to my minimum, I go up to my maximum, and there is one cycle of my function. And the question asks for 2 cycles, so I just repeat my pattern. But really, I can repeat it any number of times that I want. The cycle just keeps going and going forever in either direction. So when I get to a function like this, there's one thing you need to notice. This is not written the way we like. You need to make sure that inside here it's the factored form. So what I mean is, you might get tricked and think that you're moving the function left 90 degrees, when in fact, you're actually moving it to the right 45 degrees. You got to watch out for that. Other than that, this question is the same as the last one. I start by setting up my box, and I notice I'm going down 2, so my central axis is at minus 2. My amplitude is 4, so my maximum and my minimum are 4 on either side of the central axis. I'm shifting my whole function to the right 45 degrees, so that means my starting point horizontally is 45 degrees. And my k value is 2, which means my period is equal to 360 divided by 2, which is 180 degrees. So starting at 45, I'm going up 180 degrees to get to my end value, which is 225 degrees. The last thing you have to consider is the fact that there's a negative sign here. That means I'm reflecting horizontally. My parent function, y equals cosine of x, looked like that. If I reflect that horizontally, it ends up looking the same, has the same shape and direction. So for this instance, my graph doesn't really get affected. It's still going to start in the top left, end in the top right. Halfway between, it'll be at its minimum value. Just a side note, for horizontal reflections, when you're dealing with sine curves, the parent function, y equals sine x, looked like that. If I do a horizontal reflection, this point is now here, and this point is now here. So it actually does look different for a sine curve when you have a horizontal reflection. So back to this problem, I still need to graph my function. So I'm going to start by making an appropriate scale on my axes, and then I'll proceed to draw in the box to help me graph. So there's the box. My function starts in the top left, ends in the top right. Halfway between, I'm at my minimum, and then symmetrically on either side of that, it's at the central axis. Draw a smooth curve. So there's one cycle of my function. The question's asking me to draw this function between negative 360 degrees and positive 360 degrees. So I'm just going to draw as many of these cycles as I need. And there you have it. So to summarize, you can draw a box, figure out your central axis by looking at your C value, then figure out your maximum and minimum by applying the amplitude. Use your horizontal shift to figure out your starting point, and then you figure out the period to determine your end point. Apply any reflections to see what shape your graph follows. And you just compare your shape with your parent function. Once you've done that, just draw your box on the grid and away you go.